Indeed, I meant 10 NTU. Okay, so let's have a look at this. Okay, there was the Adelaide Coastal Water Study. Okay, this is from 2004, quite a long time ago. And the story is about, or was about, trying to explain widespread seagrass loss in Adelaide coastal waters. So what we did is we deployed moorings. Moorings are attached to a weight, sit on the seafloor and measure water mass properties over some time. Again, I show you one mooring, which is here to the south of Port Stanwix, okay, and deployed at 5 meters above the seafloor at a depth of 10 meters. So it's 10 meters, the mooring sits in the middle, and the mooring were deployed over a month, okay, a little bit longer than a month. Okay, so let's see what did we measure. Okay, and I forgot to mention indeed that the instrument also had a turbidity meter on it. Okay? We measured current speed and direction, temperature, salinity, and turbidity. And let's have a look at the result. Here's the station. There's a little special effect. If you missed it, you just have to rewind a little bit. Okay, this location here. Okay. All right, so this is what we observed. Now there are two curves shown here. It's a time series. It starts on the 6th of February 2004 and goes until for a month, a little bit longer than a month. So now the red curve is the current speed, and the units are in centimeters per second. So here on the left side, you can see that the maximum current speeds are 40 centimeters per second. And it always goes to 40 centimeter seconds, then to 0, 40, and then goes up and down. And these are the tides. Well, here you can imagine the flow comes in, maximum flow, stops, moves out, and so. And speed is always positive. Doesn't matter. It's not velocity here. It always goes in one direction, maximum speed, other direction, maximum, back and forth. So you can see the spring tides. These are the times where you have the maximum tidal currents. Okay? And you have the neap tides. We call them the Dodge tides, where you have weak currents. So however, what we also observed is this green curve, which had 0 values, and this is NTU unit. Okay, it started with 0, and then starting from the 18th of February 20th, it started to increase at that mooring location and got very high values exceeding 80 to 90, staying in that region where the mooring is for about a week, and then moving away or dissipating. Okay, and if you look at that, these are type of values, sort of the color that you get if you look at a coffee cup, coffee color. Okay, so it's a fairly dense layer of sediments. Okay, so we couldn't understand it, and there was no report, but we actually worked out, asking councils about possible events. We looked at, okay, something that actually started here during this time. There's something happened. We found something like a week before it was observed at the location where the mooring was. Okay, so let's have a look. What happened? The big sewage spill, wastewater treatment plant at Hallett Cove. This is the old one. Now they have an updated one. And what happened? Power blackout, no backup generator, Hallett Cove Beach, and they had to discharge 700,000 to 800,000 liters of raw sewage. Okay, so there was the release of raw sewage into the environment. If you look at the graph that I showed you before, this one here, it stayed in the area. It was there for a week and stayed for another week. There was a big pollution event, okay, that almost went unnoticed, okay? And you can imagine the impact that such events can have on the health of seagrasses, because a dark cloud, coffee type of color, switches off the light. Okay, and if you have an event like this over a week or so, it's a significant pollution event. All right, so let's talk about the details of actually sediments.